In this example, we're still looking at finding the limits of difference quotients. The goal is still going to be to somehow cancel out this h in the denominator. But what's complicating things a little bit now, or making the situation a little bit different, is that, again, we're dealing with an absolute value function. So we have the absolute value of x minus 1. We'll start things in a similar fashion as last time. We're just going to rewrite this problem. Instead of using the function notation, we're going to plug in our actual function. So this is going to be the limit as h approaches 0 of f of 1 plus h is going to be the absolute value of 1 plus h minus 1 minus f of 1, so the absolute value of 1 minus 1, all over h. So 1 minus 1, that's just going to be 0. 1 minus 1, both of those are going to cancel with each other, leaving us with the limit as h approaches 0 of the absolute value of h over h. So in a simpler example, h over h would just cancel out. We'd be left with 1. But now we're dealing with the absolute value of h. So that value in the numerator is going to change depending on which direction we're approaching from. So we're back to considering left and right-hand limits. So we'll start off by considering the limit as h approaches 0 from the right. So we're starting from positive numbers, working our way down to h. So if we're plugging in positive values, those absolute value bars, again, are relatively meaningless. We're taking a positive value. Its absolute value is positive. So that's just going to be h over h. H over h will cancel out. And we get the limit as h approaches 0 from the right-hand side of 1. The limit of any constant is just that constant itself. So that right-hand limit is 1. As we consider the limit as h approaches 0 from the left, we still have h in the denominator, but now we need to consider what the absolute value of h should become. So we're plugging in negative values for h, so negative 10, negative 5, negative 3. So we're plugging in a negative number, but because of those absolute value bars, our result ends up being positive. So what we're getting is the opposite of whatever we plug in for h. Again, h over h is going to cancel out. So we're left with the limit as h approaches 0 from the left-hand side of negative 1. The limit of a constant, again, is just that constant. And we have left and right-hand limits that are not equal to each other, meaning the limit as h approaches 0 of f of 1 plus h minus f of 1 over h does not exist. Again, the only way for this limit to exist is if the right and left-hand limits are both equal to each other. Since those are different, our limit does not exist.